just as a add-on at the end. I got curious and I decided to see if it was possible, if there was some way that I could actually fix that bug. And the error is in the file where that error occurred. If I do this instead, include the real Windows.h, I'll get the warning. And this is in the platform SDK base tsd.h. Okay. So the trouble, of course, is in locating. It's in. So this is all the reason why this is all gray. Unknown. So now I had to find out where is this being included so that I can insert that extra piece of code. And it's not so easy because I can't modify this file. Okay, I don't want to anyway. That's the file that is expected to have been included for everything that's been compiled in the runtime library. So I can't really modify that. Where it is anyway. But I could make my own version. And it took me a while to locate where the include of this file occurs. And I eventually, what I did was I copied this file, put the fixed line in, and then included it one line at a time, right, until I didn't get all sorts of errors about u-long, right? Like I had to find out. I want to be able to use these type defs, u-long pointer, and so on. But I couldn't until I hit Windows.h. So then I went into Windows.h, and I found that in Windows.h I could include my file, or I could start to use those types after the inclusion of WinDef. So that means that I had to go and find out what was WinDef. And I found all these things are typedef here, except not u-long is not in here for some reason. I couldn't find that. That one might come later. Anyway, so then I had to make my own WinDef to find out. Now, actually, this one might be the same as the usual one. Is there any difference? Oh, yes. Yeah, then I found out that some of them were coming from winnt.h. So then I had to make my own winnt.h, where the eventual inclusion of that base SDD thing happens. I put my own one in, where now this was supposed to be long, but I got other warnings when I put long here, possibly because this is const. Const u-long might, no, it's got to be a PTR. This is essentially the same thing. I don't think I can get rid of this. Maybe I can. I got my Windows.h. Okay, that's enough. So that's how U-long PTR works. Um, it correctly prevents the sign extension by making this unsigned, and the underscore PTR bit allows for this to be a pointer value rather than just a number. Uh, and so that's fixed. So I'd modify 4 of the base things. These are just in my own H directory. And so if I just include the special windows.h with the fix, and which includes all these other things, and eventually the one with the bug, I don't get the warning, and I don't need to disable that for the remainder of this RTL load. So that means if there are errors of the same sort somewhere in anything that so far there are none, but if there were any in any of these following files or others that may come up that I might want to include here, sometimes there are some inclusions later on that I add as I go along. Process.h, if there was an error some other error in there, I would catch it. Okay, so that's it for that. As far as what about some of those other ones? As I said, some of them are kind of silly. This one can and would have been important in that one case I showed you. Function not inline is I don't know why that's a warning. Well, it could be important, but it comes out everywhere. Right? You only want to know about this where your real intention is to inline something, to force inline. And even there's a keyword called force inline, and even that doesn't guarantee inlining. I have my own way to guarantee inlining of a function. Maybe I'll show you that one day. Now this was actually not related to this. This one is not disabled by default. This is related to my smart pointer class, which includes in its constructor a new, if you recall, that smart underscore pointer contains a new, right? In the parameter list of the object it's constructing, the base object it's constructing itself from, if new fails, which it never would, then that 5 bytes wouldn't be freed. If an exception was thrown, right? I think if an exception was thrown, right, I don't care about 4 bytes. The fact is an exception got thrown during new, right? So irrelevant. This is useless. Unreferenced functions. Well, it's not so useless. Sometimes this is useful because then you can just get rid of you can get rid of an unused function. But the fact is that often I have functions that are unreferenced in the release build, but referenced in the debug build. An example that you don't have to go far to find an example. There's one in here. Where I have 2 versions that validate the passed in arithmetic expression, and they use 2 different algorithms. Okay. Now in debug, well, it shouldn't give it to me anymore. I think it used to give it to me, and I got rid of it by doing this. In the debug build, I make sure that the two versions of the two validate versions return the same result, or else one of them might be an error. There are several cases where I use, and this is a good tool to put in your toolbox, and that is if you can think of a second algorithm to do the same thing that you're doing, right? Then in the debug build, run both algorithms and make sure that they're agreeing. And then if one of them contains a mistake, you'll be alerted to that. And an example within here, where I do, where is it? Set at one of them contains an index. Where is it? Oh, find index. Okay. Now this is a linked list thing, right? And I'm trying to find the position of an item for a given index. Now if the index is closer to the end, it's better to search starting from the end, right? Rather than the beginning. The closer to the beginning, then go from the beginning. Now, well, in this case, so I have two methods for finding this position. Now, it must be true that the two methods would agree, even if I do it in the inefficient way. The two methods should give the same result, or else one or the other of these functions has an error. So I say if the index is less than half, seek from the head, otherwise seek from the tail. But in the debug build, ahead of that, I seek from both directions and make sure that they agree, right? So that even though in the debug build this takes 10 times as long to complete, I know an error. I will be alerted of an error if one of these was wrong. In the release build, it will do the most efficient thing. Having a backup algorithm for any function that uses a different method should be ran and checked against the other method, the intended method, especially in optimization problems under debug. So, if you have a highly optimized seek function that's really efficient, you want that to be the one used in the release build. But if you have a really, really slow but grindingly thorough seek function that does the same thing, in debug you should run both and make sure that they agree. Anyway, so that's that. What else is there? Define is not defined, replacing with 0. I don't even know that it came up a lot, so I never looked into it. Now this is a weird one, and I don't really understand what it means, but it comes up in relation to that string class, where sometimes a member function is called, and sometimes a non-member function is called for the same operator class. Sometimes I want to add a string to a pointer, and like a regular string to a PS string, Yeah, if I'm adding a TS string to a regular string, a member function is used. And if I add a TS string to a TS string, a member function may be used or may not be used. So there is a little, it depends on the order of operation. Okay, but it's not important. And this comes up only under release build, but it's meaningless, pointless. This is telling you, this is the good news. Something was selected to be in line. If that's good news to you, I don't know. Inlining can be good, and sometimes it can be bad. One of the reasons for forcing inlining, for instance, that came up once for me was in connection with our games, and what I wanted, what I had was a check to see if it's the full paid for version or not, right? Now, I turn that into like a function I can call is a demo or something. Now, if that function call is a regular function call, it's very easy for a hacker to turn that off by simply finding out where that call is and making it return true. But if you inline the calls, right? If you inline that function, then that code is reproduced all over the place, and it's much more difficult for a hacker to go and find every location where that code is reproduced. So that was one reason for wanting inlining. Okay, so this is just a, I don't know. This is a tutorial, I guess. A tutorial about warnings and about maximizing your chances of locating bugs, right? And we just found a new bug. Running through this, we found out that there are bugs in that STL thing where it's incorrectly using the expression assert. It's a real bug, right? They didn't find it. The reason they didn't find it, the assertion is disabled. Okay, see you next time.